Welcome to The Explainer. Okay, today we are exploring a massive shift in how we teach and learn the sciences. We're looking at how virtual labs are completely reshaping STEM education. They're taking these traditional, heavily resourced, and let's be honest, often restricted experiments and transforming them into highly accessible, interactive digital realities. So if you want to understand where the future of science education is heading, you are exactly where you need to be.
Okay, let's dive into this. Think for a moment about the traditional limitations of a physical science lab. We are talking about incredibly strict schedules, limited physical space, wildly expensive equipment, and, oh yeah, let's not forget the actual physical hazards of mixing volatile chemicals or handling dangerous biological materials, right? So the big question is, how do we take those complex, potentially hazardous experiments and make them 100% safe and available to literally any student at any time? To answer that, here's a quick roadmap for today's explainer. First up, we'll look at what STEM tools actually are. Then we'll explore breaking physical lab barriers, followed by the 5 virtual lab benefits. After that, we're going to zoom in and go inside a PraxiLabs simulation to see it all in action, before wrapping up with the real impact and results. Basically, we're going from the macro view of educational technology right down to the micro details of gamified simulations. Let's get into it.
All right, Section 1. What are STEM tools? Integrating science, technology, engineering, and math. See, modern educational technology is actively tearing down those traditional walls that used to totally separate these 4 core disciplines. And this brilliantly illustrates what integrated STEM teaching tools actually are. By definition, they're educational technologies. Think virtual labs, augmented reality, 3D modeling, that combine engineering and tech with science and math to really enhance hands-on learning. It beautifully shifts the focus onto the process and the design of solutions, rather than just, memorizing the answers. Instead of merely reading about a complex scientific mechanism or struggling to picture chemical compounds in their heads, students actually interact with them in a cohesive digital framework. When you remove that friction of abstract theory, students actually learn how to think like real-world engineers and scientists.
So that necessary shift to digital spaces brings us right into Section 2, breaking physical lab barriers. Because let's face it, theoretical classroom explanations simply aren't cutting it for the modern digital learner anymore. We are looking at a really stark contrast here. On one side, you have the traditional physical lab. It requires expensive equipment, constant restocking of consumables, heavy maintenance, and it carries real-world risks. Plus, when the bell rings and class is over, your experiment is over. On the other side, modern virtual labs are completely cost-effective and give you 24/7 access. And honestly, the best part? They are entirely risk-free. You can accidentally mix the wrong chemicals and completely blow up your virtual lab just to see what happens, and there are absolutely no real-world consequences. No danger, no paying for broken beakers, no cleaning up the mess. That kind of freedom is absolutely incredible for a curious mind. Let's move to and see how this builds right into Section 3, 5 virtual lab benefits. This is all about how these digital platforms are actively transforming the educational experience through specific pedagogical advantages. So there are 5 massive benefits reshaping how students learn right now. Number 1, safe, risk-free experimentation. This encourages pure curiosity without any danger. Number 2, cost efficiency. It optimizes resources for the institutions, freeing up their budgets for other things. Number 3, deeper conceptual understanding, because students actually visualize data trends and molecular structures in real time. Number 4, and this is huge, unlimited practice and accessibility. A student can repeat an experiment as many times as it takes to master it through trial and error, which guarantees equal access regardless of their school's location or budget. And finally, number 5, enhanced engagement. They use gamified elements that make learning genuinely enjoyable. Now you might be thinking, okay, this is just for basic high school chemistry. But it goes so much deeper than that. Virtual simulations empower disciplines that rely heavily on risk and highly complex systems. We're talking advanced physics, biology, engineering, tech, medical and health sciences, environmental science, and even complex modeling in business and economics. The application spans across incredibly advanced, nuanced fields. All right, let's transition to the how portion of our explainer with Section 4, inside a PraxiLabs simulation. We're zooming in on the action to see how a platform like PraxiLabs specifically structures and gamifies this whole learning process. To really grasp this, let's walk through an actual simulation. Think about the amylase test. Step 1. Students enter a 3D virtual space and physically interact with their lab tools using their mouse or touchscreen. Step 2. They manipulate variables. In this case, they're testing how different temperatures actively affect enzyme activity. Step 3, they observe the chemical color changes and analyze the results. They aren't just following a static, boring recipe. They're actively testing variables, observing the outcomes, and drawing their own independent conclusions. Abstract theory immediately turns into a hands-on digital reality. Now, what's really interesting about this slide is how the platform handles real-time guidance. Inside PraxiLabs, there's actually a virtual lab assistant named Oxi. So when a student is working through this immersive 3D environment and inevitably gets a little stuck, Oxi provides instant feedback, hints, and corrections. It's a real game changer. It keeps students actively exploring, testing their hypotheses, and learning from their mistakes right in the moment, instead of just throwing their hands up in frustration or passively watching a video tutorial. It bridges the gap between theory and practice beautifully. So we've seen the software. Let's zoom out now to our final section, real impact and results. It's time to look at the tangible, real-world impact these tools are having on actual students and academic institutions. To ground this technology in a human experience, let's look at some feedback from Salma H. Qatari. She's a PharmD intern who participated in a usability testing session for PraxiLabs, and her experience completely validates this shift. She notes that the platform is making a real impact in digital education, and she highlighted how rewarding it was to see user feedback genuinely valued and implemented. Basically, this isn't just software built in a vacuum, right? It shows that these tools are being built by and for the scientific community, and they're constantly evolving based on how actual students interact with them in the real world. So the crucial point is the data. Utilizing highly engaging, interactive virtual labs can boost learning retention by up to 80%. Think about that. When students are allowed to fail safely, try again immediately, and visually connect with abstract concepts, the information actually sticks with them. That 80% retention rate is a staggering achievement for educational technology. And it directly translates into tangible outcomes. Alongside that massive retention boost, platforms like PraxiLabs are often shown to boost student performance by 60% compared to traditional learning methods alone. Simply by removing the barriers of cost, safety risks, and limited lab access, students just perform better. It's that simple. Which leaves us with this final thought. We've seen how virtual labs optimize resources, enhance safety, and drastically improve both student retention and performance. So to all the educators, administrators, and lifelong learners watching, are you ready to rethink your science curriculum and embrace the virtual lab revolution? Because the future of STEM education isn't just locked away in a physical classroom anymore. It's waiting for you in the virtual world. Thanks for joining me for this explainer, and keep exploring.